And thus trig begins. Section 3.1 is called periodic phenomenon. What we're going to be doing today is thinking about the idea of periodic situations and periodic motion to get a basic understanding. When we're talking about a periodic relationship between two variables occurs when the output values, so the y values, demonstrate a repeating pattern over successive equal length intervals. Most importantly in all of this, the period of a periodic function is the length of the input values that it takes for the function to complete one cycle. So the period is the length of the input values that it takes for the function to complete one cycle. If we're looking at this image right here, do you see how the shape goes like diagonal, flat, diagonal? Diagonal, flat, diagonal. Do we see that? That has a periodic motion to it because we're repeating the up, sideways, down, up, sideways, down. I'm going the opposite direction than you're looking because y'all are looking at me, but you get it. Of this motion, of these outputs. It wants us to draw two additional periods for the graph of f on the axes above. So if we notice this shape, diagonal, across, and down, repeats over and over again, we can apply the same pattern, finishing the graph further along the input values, meaning from 7 to 9, I can also go diagonal up. From 9 to 10, I can go flat. From 10 to 11, I can go diagonal down. Do we see how I added another one of the shapes? Yeah. I continued, like copy-pasted the period over and over again. We do one more because it asks for two additional periods, so we go from 11 to 13 diagonally, from 13 to 14 flat, and from 14 to 15 diagonally. And boom, we've drawn two additional periods on this function. Now that we understand the concept of what a period is, we need to be able to answer the question, what is the least possible value of a period? So if we look at this shape here, we see there's some repetition. But what we need to do is we need to figure out how long it takes, how long is the input interval before we start to repeat the shape. So what I like to do is I like to, if it's easy, to start on the y-intercept. So put your finger right here. I want you to follow the shape until you're in the same spot. So the first thing I should be doing is going down, then it comes up, then it goes sideways. I'm waiting until I go down again to stop. This little shape right here that looks like a Nike check mark sort of, that is one period. Do you notice how that shape would repeat again and again and again? So how long is the period? 5 seconds, because we started at 0, and when did that period stop? 5. So the least possible value of the period is 5 seconds or 5 units, whatever the interval is. It is usually time, so 5 seconds. But since we know this shape repeats over and over and over and over and over again, we can use the concept of this length 5 period to answer questions like example 3. It asks me to evaluate g of 14, which normally I would go to 14 on the x-axis and see what the output is. But can I see 14 on this x-axis? Yikes. So I need to figure out where we would be in the pattern if we were at 14. So what I'm going to do is I'm going to take the number 14 and I'm going to multiply, or I'm going to divide it by 5. 14 divided by 5 would be 2 with how many left over? So it's 2 times 5 plus 4, because 2 times 5 is 10, and 4 makes 14. But the 2 times 5 part, this section of 14 is just repeats of the same motion, which means I could really just evaluate g of 4. And g of 4 is something I can see on my screen. When the input value is 4, what's the output value? 7. Let me go over this again by pointing at the screen, so maybe this would be helpful. We can't see 14 down here, but we can repeat this shape every 5 units. So we could go 0, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 11, 12, 13, 14 is the same place. Because that same shape's going to repeat like a stamp over and over again as we kept going. So I just count how many 5s I can get, find the remainder, and evaluate that number. In which case, if we're doing G of 72, way off screen, am I right? What's 72 divided by 5? Maybe the better question is, what's the remainder when 72 is divided by 5? 2. Because 14 times 5 is 70. 70 plus 2 is 72. So my remainder...
So would you do it 14 times plus 2 more?
Yeah, so I would go like 14, or sorry, 1 through 5, 6 through 10. I do that 14 times, I'd be at 70. I just have 2 more. Which means I only need to evaluate at 2. When the input is 2, what's the output? 6. Yes. Yes. If we try this again, let's do negative 17. Negative 17 divided by 5 is what?
It would be...
There's
It would be 3.
remainder of 2.
Okay, I hear a lot of good things. If we write it like this, negative 3 times 5 is negative 15, right? And I'd still need to subtract 2 more. So this is where I heard somebody say remainder of negative 2. Can we see negative 2 on my graph to evaluate?
No. Oh,
I did not
wait.
say negative 2. Yes. I said 2.
Wait, yes,
Oh.
to the left.
We actually can see it because it would be right here, correct? Yeah. What's the output value? But if you didn't want to answer that way because you're like, I don't really want to work with negatives, if we added 5 to this number, the period length, we'd be at G of 3, right? Look where G of 3 is. What's the output again?
7.
It's in the same spot. Any multiple of 5 is going to give you the same output value in this periodic phenomenon. So either way you look at it, of G of negative 2, or 5 more than that to repeat the shape, G of 3, you'd get the output of 7.
Wait a minute, I'm so confused. Like, what is a 7 and a 6 and 7?
That's the output value. So like, how high is it at when we're at G of 4? It's at an output value of 7.
Is there like any specific way to solve it? Like, hold on.
By solve, what are you meaning?
So you know how like we're doing like 14 times 5? Like, is there any other way to get to that? Or?
You can really just think to yourself, what would be the remainder if I had multiples of 5 making this number? Because we'd go...
It depends on like on the seconds.
On the period, yes. If my period wasn't 5, I would be dividing by a different number and asking you for the remainder.
So the G of 5 comes from the remainder.
Yes.
And so, how do we know that's right? Like the 7 and the 6.
If we had a graph that could be zoomed out and we kept zooming this direction, like moving our graph this way, we'd eventually reach those numbers. But remember, this pattern repeats over and over again. So we could say this 5-second pattern goes from 0 to 5, from 5 to 10, from 10 to 15, from 15 to 20, on and on, knowing that the exact same outputs are occurring every single time.
Yeah, but I'm understanding the like the 7 and the 6.
If it's just the output here. So for this one, G of 2, input of 2, what's the output?
6.
And every 5 after that will still be 6. Watch this. 1, 2, 3. Hello, I just counted wrong. 1, 2, 3, 4, 5. We're still at 6 because the pattern repeats.
Okay.
Shane, what's up?
What if it is more than negative 6? Like, let's say the final number would be more than negative 5, and it would still go into the negatives.
You'd have to add the period back to it so that it gets on screen, essentially.
Until just keep adding.
Until you can answer the question. Keep adding or subtracting the period, yes. Let's try another example that's maybe not a graph, because maybe the graph is what's getting us. Let's see a different representation. Example 4 says the graph of H is periodic with a period of 5. Look, they already told us what it is. That's nice. We didn't have to count it ourselves. Values of H are shown at selected values of X. Find the following values. All right, we want to know what h of negative 2 is. Unfortunately, negative 2 is not one of the x values on my table. But what if we added the length of the period to this number?
You would do
Negative 2 plus 5. And what is negative 2 plus 5?
3, and you would get 4.
Well, if we plugged in 3,
0.
we'd get out 0. Inputs on top, outputs on bottom. You're doing inverse in your head. Okay, let's try this again. H of 6, but unfortunately 6 is not on my table. So I add or subtract the value of the period, which is 5, until I find one that's on the table.
Okay, that one is way easier.
We subtract 5, we get negative 2, yes?
I know if you subtract that.
I just, honestly, you have to think about it. We had the number 1 on there. 6 minus 5 is 1, and I knew that would work. 6 plus 5 would be 11, not on my list. What about h of 9?
You said what now?
Correct. H of 9, starting on the inside, is not in my table. But what is, that is 5 units away? 4, right?
So you would do 3, and then you would do 3 again. Would it be 0?
It would. So h of 4, which would be the same, h of 4 is 3, and h of 3 is 0. You work from the inside out when we have composition.
Okay.
Now this last part says, interestingly, evaluate h of 5k minus 3 where k is an integer. Do we know what an integer is?
Yeah,
It's just been a minute.
It's just been a minute since we defined it. Can you give me an example of an integer?
1.
Great, 1. What else?
2.
2, 3, negative 5, 7. Essentially, whole numbers plus 0 and negative numbers are integers. No decimals, no fractions. So we're saying 5 times any particular number minus 3 will give me a number in this table. What was the length of the period again?
5.
5. So this part right here is just telling me any repeat of this pattern. 5 times k is any repeat of the pattern minus 3, which is really like asking me, what is h of minus 3? Which is really like asking me, what is h of 2? Where did I get the 2 from?
You do
No idea.
plus 5.
Negative 3 plus 5.
5.
That's not on my table. Plus 5 again,
You do 7, it would be 2.
it would be 2. So when we have periodic phenomenon, we can add and subtract the value of the period to repeat the output values in the graph in the table.
Wait, can you explain that?
Yeah, the last one. Where it says 5k, where k is an integer, because the period length of this function is 5, this is just saying any repetition of k. In this one, if k is 0, 5 times 0 minus 3 is negative 3. If k is 1, 5 times 1 minus 3 is 2.
Oh my god, that's so
If k is 2, 5 times 2 is 10 minus 3 is 7. Yes?
This type of question, will the period always be in the question? Or
That depends. Sometimes it's given to you, like the table was. Sometimes you can find it easily, like the graph. And sometimes the table will make you find how long the period is as well. So it's a varying degree of difficulty. That was a good question. So these periodic functions start with a basic pattern and then translate the pattern itself repeatedly over the domain. As a result, we can consider a periodic function a horizontal translation of itself, like a stamp, over and over and over again, taking the same shape and moving it to the side, and then moving it to the side, and then moving it to the side. In example 4, the period of h was 5, meaning that we could translate the graph horizontally 5 units and end up with the same graph. Therefore, it satisfies the horizontal translation there, where h of x is equal to h of x minus 5. That's, again, just saying the same pattern scoots over the length of the period over and over again for all of eternity.
It's constant. It's
The period will be constant, yes. The period length will not change. Let's hop to the back. We have one more example just dealing with the period here. It says the graph of H is, hello, that says F. The graph of F is periodic with a domain of all real numbers. 2 full periods of F are shown in the graph. Find all output values of F that yield an Let me read that again. I'm having a very Monday, Wednesday. Find all input values of F that yield an output value of 1. Here's some keywords I need us to underline. The words all input values. All input values means that we're going to have to find an infinite number of answers, which sounds really annoying until I teach you how to do it. Okay, let's back up for a second. Let's look at our graph. What is the period length of this graph? How long does it take for us to start and finish the shape?
It was 5. And then you was gonna be going back down and up.
Isn't it 4?
5.
It's 4.
Yeah.
Even though it, look, it starts at 1.
Yeah.
So this is
Oh.
1, 2, 3, 4 from 1 to 5.
Wait a minute. Hold on. Say that again.
You didn't start at 0.
We didn't start at 0. We started at 1 and ended at 5, which is 4 units long.
1, 2, 3.
Okay, so the period of this function is 4. We get that. We want to know all of the input values that would give you an output value of 1. Okay, an output value of 1 means I'm looking on the output value of 1.
4.
Based on what I've just highlighted, what are the input values that give me an output value of 1?
2 and 6.
2 and 6. Cool. But remember,
Wait a minute. What?
Because you highlighted it and then.
yeah, here's an output value of 1.
Oh.
This happens at an input value of 2 and an input value of 6. Now remember, it asked me for all of them. And we know that this periodic function goes from negative infinity to positive infinity. So if I were going to continue the graph going this way, what would be the next time?
10.
10, and then,
14.
and then,
18.
okay, we get this, right? But we'd have to keep going for forever, and we haven't even gone the negative direction.
What'd you do?
We would need -2 and -6 and -10. And your faces you're making at me are correct. I don't want to list them all out. That would be wildly annoying. So instead, we write what's called a general equation. What you will do for a general equation,
Isn't it just
you tell me x equals to whichever one you want to start with. For me, I always start with the first one I see, 2.
X.
Then you're going to add the period length 4 multiplied by k, given that k is an integer.
I don't like that.
2, 6.
And I'm going to teach you this notation. I know it doesn't mean anything to you yet. There is mathematical notation for the phrase k is an integer.
Is this one of our formulas?
No.
Is that like
What is
a
that?
double Z? I don't
You know how you make the fun and funky r for all real numbers?
It's just a Z.
Integers is a fun and funky z. If you want to watch me do it, watch the screen. I make a regular z, and then I join up at the top and I make a second z.
It's not just supposed to be a K.
This is a k. That's a cursive k.
Yeah.
Is that confusing y'all too? Should I make that print?
Wait, what's next to the K?
That is the mathematical symbol for is an element of. K is an element of the integers. Which just means give me any multiple of 4 and add it to 2. All of those will be places where the output value is 1. Yes? One of our end goals in learning about periodic phenomenon is to answer questions like example 6. Now, this is one of the FRQs that you will have on your test. Every single year, there will be one question that is the exact same questions I'm about to ask you, minus one part that we haven't learned yet, with a different scenario. So you will see this over and over again. It takes a lot of reading, a lot of thinking, so let's start together. It says, the figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. At time t equal to 0 minutes, the minute hand is pointed directly up to the 12. However, the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up to the 12 is at time t equal to 30 minutes. As the minute hand moves, the distance between the end point of the minute hand and the floor periodically increases and decreases. The periodic function h models the distance in inches between the end point of the minute hand from the floor and the floor as a function of time t in minutes. Whoa.
That was a lot further.
It was. Let's label some things. How far above the ground is the center of the clock? 120. So everybody right now, draw a line through the center of your clock, and I want you to put 120 inches. Some of the other numbers it gave me is how long the minute hand is. How long was the minute hand? 8. So we're going to put a number 8 inches here to show me how far this is. One of the other things it gives me is the 2 times at which that minute hand is all the way up. What is the first time the minute hand is all the way up?
0.
And what's the second time? 30 minutes. It's a broken clock. It's a broken clock. Okay, here's what we know now. If we wanted to answer part A, it says the graph of H and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, and P are on the graph. No scale is indicated and no axes are present. Determine the possible coordinates T and H of T, so inputs and outputs, time and height, for the 5 points. Let's start with time. If we're looking at our clock, we've already answered this question. What is the first time the clock is farthest from the floor? At 0. So my first time input is going to be 0. Then the clock starts going and the minute hand goes down and then the minute hand goes up. When's the next time the minute hand is all the way up at the top?
At 30.
At 30. Now if this is time and time moves continuously, if the top is 0 and then 30, what's the bottom? 15, halfway between it. That makes sense. And then if this is 0 and this is 15, what should G be?
7.5.
7.5, halfway between 0 and 15. I'll go back. What about halfway between 15 and 30?
Would it be?
No, I would never get that.
22.5. So 7.5, 15 plus 7.5.
Wait.
Oh, I had 20. Oh, that's wrong.
Okay, let me pause and go back for my time. When we were looking at this situation, you guys told me that the first time the minute hand was up at the top was at 0. And the second time it was up at the top was at 30. So I need to make sure that my picture of the distance where it's at top is 0, and the next time it's at top is 30. Does that make sense? In between there, we have equally spaced coordinate points. So halfway between the top points should be the bottom. So what's halfway between 0 and 30? 15. Halfway between the top and the bottom should be the middle. What's halfway between 0 and 15?
7.5.
Then halfway between 15 and 30, 22.5. Do we feel okay?
Yes.
So we have so far determined the times at which our minute hand is up high, in the middle, down low, in the middle, up high. But up high, in the middle, down low, in the middle, up high have heights. If we are looking back at this again, what is the middle height when the minute hand would be in the middle? 120. I want you to put this number right here, 120. If our little dot that we're measuring is at the very end of the minute hand and it's all the way up, how high would it be? say your answer again, but think differently.
800.
I don't know.
She said 8. Why did she say 8?
Because the 8 inches?
Oh,
It's how long the minute hand is. So actually, how tall is it when it's all the way up there?
Wait, 128.
128, because it's 8 inches above 120.
I get it.
So how low does it go if that minute hand is all the way pointing to the bottom? 112. So here's the deal. These heights have to make sense. The taller number, the bigger number has to be on top, the middle number has to be in the middle, and the smaller number has to be on the bottom. But after that, you've already answered the rest of the questions. The outputs on top both have to be the same. They're 128. The output on the bottom has to be the opposite direction, which is 112. And the heights in the middle are 120. We are describing how tall that minute hand would be at every particular time.
So that definitely was the easiest.
Does that make sense?
Yes.
Now, here's a bonus question for you that doesn't have anything to do with these questions. What is the length of the period for this motion?
huh?
Oh,
Repeat the
Wait,
question.
hold on, like these.
What is the length of the period for this motion?
Wait,
Positive and it's increasing.
Oh, this is not a question on here. This is not a question on here. Just in general. Remember, what was period? We defined it on the other side.
it was like 5, one was like 5, right?
it's 30.
It's 30. Remember, a period is how long it takes to go from one part of the shape to the other. Isn't that one repeat of the shape?
Right.
Then it would keep going, then it would keep going, then it would keep going around in a circle. For the person who said 360 degrees, I get what you're saying, but we were talking about the distance between the ground and the end of the clock, not the rotation. I like it. Save that for later. Okay, we are describing the motion. We are describing the distance in inches between the end point of the minute hand of the floor and the floor, which is increasing and decreasing as the finger of the clock goes around. High, low, high, low. Yes? It's confusing. I know that. Welcome to Trig. But to go on, this is part B of this question. This is actually going to be part C of the real FRQ. It'll take us a few lessons to get the actual part B in here. But this question has been floating around this class since topic 1.1, which is August. It says, refer to the graph of H in part A. The coordinate of G is T1 and the coordinate of J is T2. So what I want you to do is color in, highlight, indicate the section between G and J for yourself. I already highlighted mine blue, so I couldn't highlight it again, but I want to focus mainly on the section between G and J. On this interval between T1 and T2, which of the following is true about H?
So it's definitely decreasing.
It's definitely decreasing, so let's get rid of the ones that say increasing.
It's negative. Isn't it?
Here's the thing. If we're talking about H, we're talking about the outputs.
Numbers, right? It would be positive.
Are the outputs positive or negative? Positive. So that means B is the correct answer here. The outputs are positive, but they are decreasing.
I'm not looking at anything.
Now, part 2 says, on the interval from T1 to T2, describe the concavity of the graph and determine whether the rate of change of H is increasing or decreasing.
Don't tell me it's not writing.
It's the writing one.
I don't even remember.
Would it
I
be
don't know
concave
how to
and
write it,
up?
but I know what it is.
Without writing it perfectly, let's answer the question. Is this graph concave up or concave down at this point? Concave up, which means is the rate of change increasing or decreasing? Increasing. Now we just have to write it correctly. And the reason you're panicking about writing correctly is you're trying to memorize it. We're going to read the question and rewrite the question. It says, describe the concavity of the graph. So we write, the graph of H is concave up. You guys just told me that. And look, half those words I just took from the question. The graph of H is concave up on the interval from T1 to T2. And again, I didn't have to memorize that. That's in the question. And then it asks me to talk about the rate of change. We repeat those words. and the rate of change of H is increasing. We did not write the word it. We wrote a very clear answer. The graph is concave up. The rate of change is increasing. The graph is concave up. The rate of change is increasing.